Our next unit starts with a little information about circles, some of which you might already remember. Circumference, remember, is the same thing as perimeter. It's the distance around. But the word circumference relates only to circles. Arc length is talking about a piece of the circumference. So if circumference is all the way around, arc length is talking about, like, if this were a fence or a piece of string or something. An arc length, for instance, maybe I just want to find out how long is it from here to here. Maybe I have like a door or a window or something on here. And I need to figure out the length just from here to here of this piece of string or this piece of fencing here. So that's what we're going to figure out. Not only the distance around the whole thing, but sometimes just the distance around a piece. So, quick reminder again, circumference is the distance around a circle. It's the perimeter. You might remember the formula as pi times diameter, or 2 pi times the radius. Remember, d stands for diameter, r stands for radius. The diameter is all the way across, and the radius is just halfway. Okay, so anytime we're talking about all the way across a circle in any direction, that's the diameter, and radius is just halfway. Also, a quick little reminder here about pi. Pi is a Greek symbol, and it represents a ratio, and this is the ratio it represents in all circles, no matter how big. So as big as the Earth or as tiny as the tiniest little circle you can imagine, it's the circumference, the distance around, divided by the diameter. That's what the ratio pi represents. And it's always going to be that constant ratio. So an example of something that we're going to have to do is, for instance, find the circumference. So I have a circle, okay? I'm going to find the whole thing because it says C, or circumference, okay? I know the radius is 9. So I'm going to replace 9 in for R. And to know sort of like which formula you would use, well, did they give you the D or did they give you the R? It's kind of an easy way to think about it. So I'll use this formula here. I did it both ways so you can see no matter what, you'll get the same thing with that formula. So in this one, I decided that I wanted to use the distance all the way across, which would be 9 plus 9, which is 18. Or in this one, I did 2 times pi times the radius, which is 9. And notice again, I still get the same thing. I put both of them on there because sometimes people just like the one formula. So sometimes people just like this formula and they ignore this one and pretend it doesn't exist. But you can do whichever you want. Let's take a look at another example. So sometimes you're given the whole thing. So this time we're given the circumference all the way around, and they want to know how far across is it. So I have 26 meters of fencing, and I want to know how much that's going to give me in space, how far it's going to go across. So again, I'm looking at the setup for both formulas here. I'm trying to find D. So for me, I'm just going to ignore completely this other guy. Like, it's just, I don't need extra information on that one to think about or consider. So I am just going to replace C with the 26, which we did. That's the circumference. And pi, again, we're representing as 3.14. And D, so I'll divide by 3.14 to both sides, and we get 8.3 meters all the way across. So the last section was a little bit of a review. We've looked at circumference before in your past. You've seen it before, the distance around. So now something new. The arc length. Again, this is just a piece of that circumference. So remember that circumference is all the way around. So that's C, the whole thing around. And this arc length here, this is just a piece of that circle. We want to know what that is. So that's what we're going to do next. And that's something that's new to us. So it's the ratio of the length of an arc compared to the whole thing, to the circumference. So let's take a look. Excuse me. So we can take a look at this in a couple of different ways. We can relate it in terms of degrees. So we'll do that one first, like the degrees of a circle. So remember, a circle has 360 degrees, okay? And if I'm looking at this as kind of like a section, What I want to know is if I have this section here, how many degrees is this? Or like what fraction of the piece of the pie is this compared to that 360 degrees? Okay, so that's what this guy kind of helps us to do. So a couple of different things. So here is this, these ratios here. So it's saying that the arc length over 2 pi r, remember that's the circumference, that's the whole thing. So arc length over 2 pi r is equal to the measure of the arc over 360. So again, it's that chunk of the piece of the pie. Like maybe this was 60 degrees, this little piece of the pie. And we can also kind of relate it in terms of pi. So again, if I have that arc length over 360 and I multiply it by 2 pi r. Okay, so we're going to take a look at a couple of those. Also, it's kind of helpful to have this little diagram here. Remember that the whole thing is the circumference. And if they ask just for AB, arc AB, and that's represented by the measure of arc AB, and that's how I get that little arc, is that just that little dome guy over the A and the B. That's how I represent the arc. Okay, so let's take a look at an example. So here's an example of something that we're going to take a look at. So find that arc AB. So here's another example. So I just want to know how far is it just from here to here. So not the whole circumference, but I want to know just from here to here. I know that the radius right here they've given me is 8. And I know that this arc right here, this arc measure is 60 degrees. So this little angle, this little angle measure here is 60 degrees. So I want to know how long is this arc right here. What's the measure of that arc? Okay, so here's what I'll put. So you can see what I replaced in my little highlight here, 60 degrees, right? We talked about that out of the 360, right? That was that little piece of the pie that we talked about, times 2 pi r. And that was this little bottom guy right here. So this little guy right here is what we're using and replacing. Okay, I got the 8 from the radius, right? And then I can figure out the rest of it. So the rest of it I can use in my calculator. 60 divided by 360 times 2 times pi times 8. So you can see what I replaced. I just simplified this guy to 1/6. You can let your calculator do that. You don't have to if you don't want to. And then notice the pi I replaced with 3.14. And when I multiply that out, I get 8.4. Okay. All right, let's take a look at one more of those guys. This time it wants me to find C. It wants me to find the whole circumference. So it's given me, you see right here, this arc length of 4.19. I see this little angle measure in here is 40 degrees. But this time I want to know how long is the whole entire thing. So I just know this little piece of the circle. Now I want to know the entire circle. Okay, so you can see that top ratio that we were using here, that comparison. So I have 40 degrees, right, out of always 360 is a circle, right? 4.19 is the measure of the arc, right? This time it's XY, sorry. So we replaced that in. And so this time C is actually what we're looking for. We're looking for the whole thing. Okay, so I'm going to cross multiply. So I'll multiply either this, like I don't have to simplify that first on my calculator. I could multiply right here if I wanted to. 360 times 4.19 and divide by 40. And I'm going to get 37.7. So I simplified this here to 1/9, but you certainly don't have to do that. And also remember these wiggles, that means approximately. All right, now we're going to take a look at this guy right here. We're going to try to find the measure of RS. So we're given this radius here is 15.28, and we're given this arc here is 44. So this time again, we're trying to find like this piece of the pie here. We're trying to find that degree measure. So that's the part that's missing, that degree measure out of 360, again, because all circles are 360 degrees. I know RS was given, so I'll be able to replace that here with 44. And then I know 2 pi, and then the radius is going to go right there. Okay, so that's the piece that's missing. So 44 is coming in here, that arc measure, 2 pi r, and I replace that with this. So again, we'll cross multiply this and divide by this. So we're going to let our calculator do all the hard work on this one. And we find that my arc measure is 165 degrees. Notice this is a nice obtuse angle. This is a big angle. That makes sense that it should be a fairly large number. All right, one last new part today is we're going to convert between degree measures and radians. So that's something that's a little bit new to us. So from degrees to radians, what we're going to do is we're going to take 2 pi radians over 360 degrees, or what that tells us is that it's pi radians over 180. We'll explain what that looks like in an example here in just a minute, but this is kind of the key guy right here, pi radians over 180 degrees. And then to go from radians to degrees, so to go backwards, to go the other direction, they get flipped. Notice that. It'll be 180 over pi radians. I'll multiply by that. All right, so let's take a look at an example. They want us to convert 45 degrees into radians. What they want to know about a radian, so a radian, it's just a different way of explaining this piece of the pie. So if I have 45 degrees, so let's see if I can kind of draw this. Probably be kind of bad, but that's okay. I know this is about 90 degrees, right? Like if I make a little 90-degree angle, and if I chop that in half, that would be about 45 degrees, okay? Well, another way to talk about circles is in terms of pi. All the way around a circle is 2 pi. All circles are all the way around 2 pi. If I go just halfway around a circle, so that would just be 1 pi. So this is the whole circle. All the way around is 2 pi. So just half of a circle would be pi. Okay, so I got chopped in half. If I chop this in half again, it would be pi divided by 2. So that would be for a quarter of a circle. And now for 45 degrees, if I chop that in half again, that would be a fourth, or pi over 4. Okay, so that's an example of a picture. If that doesn't make any sense to you, well, that's why they gave us this little guy. So if I have 45 degrees and I put that over 1, and remember it's pi over 180, right? That's what we had up here in our conversion. I just multiply across. 45 times pi and 1 times 180. Well, 45 over 180, I can use on my calculator and I can help simplify it. It actually just simplifies to a fourth. And so I have 1/4 pi, or pi over 4. That's what it's in terms of radians. And remember, radians works in terms of pi. All right, and the very last one today, we're going to look at converting to degrees. So this time they give us in terms of pi. So remember, a whole circle is 2 pi. Well, 3 out of 2, or 1.5, okay, so not quite to 2, so we're not at a full circle, we're 1.5. So remember, a whole, this guy, and a half. So can you imagine what degree measure that might be? Let's take a look at it in terms of our little formula here. So we have 3 pi over 2 times 180 over pi. Remember, that's how we're going to convert from radians to degrees. So the pi's are going to cancel out here. 2 and 180 would simplify here. I multiply across and I get 270. Again, you can let your calculator do most of the work on this one, especially after you cross out your pi's here. You can let your calculator do the work. And think about that. Did it make sense? This was 180 degrees, right? So that's 1 pi, and then another half. So it would be all of this circle. Would that make sense that it's 270 degrees?